Hi everyone, I'm very excited to be here to present to you MetaLab. So MetaLab is an interactive tool to encourage people in our field, which is infant language research, to use more meta-analytic techniques. So actually, we were two very independent teams, one in Paris and one based in Stanford, that were having the same idea at approximately the same time. And we met at a conference and we joined forces, and that's where we're at now, also with the aid of a SMART grant. And why we thought about doing meta-analysis is because infant studies might be uniquely vulnerable to false findings. Babies' data are very hard to collect, so we have very small sample sizes. Yesterday I was here sitting at a table with economists, so I think you will really laugh about our sample sizes. We have very small sample sizes. If we have a sample full, we are so happy that we will never think of replicating something. And also in each study, we have very noisy measures because one baby can only sit through a few trials. So all of this are factors that are already bad within a study, but then also we have factors across studies that make it hard to compare them. Like we use very diverse methods to study a certain ability, and also infant abilities or how we measure them change very rapidly with age, and it's very hard to keep up. So we started, based on all these considerations, to do meta-analysis of these data sets, but we also tried to integrate different meta-analysis in one field into one framework, which allowed us to look at factors across meta-analysis. For instance, if you were interested in how a certain method does, you could look at several meta-analyses where some of the studies would use a certain method to compare them across. While building our infrastructure, we also thought about trying to deal with a few other shortcomings that traditional meta-analyses have. So one of them is related to the way meta-analyses are usually conducted that leads to certain biases. So meta-analysis is usually just a snapshot in time whenever the meta-analysis thinks of conducting the meta-analysis, and any data points that come out after that are a bit hard to integrate. It is also the case that certain meta-analyses might have very certain hypotheses about things, and even if it's not conscious, they might use specific search terms that can make a meta-analysis biased, and all of that is even made stronger by the fact that meta-analysis, once they're published, they're usually not searchable or usable by other researchers to bring other aspects in there. A second set of issues is related to the usage of meta-analysis. So for creators, there are high hurdles because one has to learn all sorts of techniques and build a framework to conduct a meta-analysis. And for users that just want to look at the effect sizes in a certain data set, it can also be very hard if they don't know how to use these effect sizes, for instance, to make sample size decisions. So based on all these considerations, we created something that we call MetaLab. Right now it is focused on infant development, but we hope that this can be a more general framework for other fields of at least psychology too. So I just first walk you through the elements of MetaLab, and then I just give you some examples of things that we have learned in our field using these data. So the core of MetaLab is having individual meta-analysis assembled together in one specific format. So one can click on each of these meta-analyses and look at the data set, download the data set, explore the data, look at what publications have been out based on this data set. Another element we have in there is that sorry, it's not very nice. Maybe it was the conversion to PDF, but you can read it, right? So we have a visualization tool where you can visualize, make classic visualization of funnel plots, forest plots, things that you do in a meta-analysis. Just with one click, you select a certain data set. You can select moderators like age range, so researchers can very easily look at whatever phenomenon they're interested in, as long as it's included in the website. We also include experiment planning tools, so the same thing, you can click, drag, see, okay, I want to look at word recognition studies in an age range from 12 to 16 months of age. How many babies would I need to test based on previous studies to have 80% power? And then we also encourage data addition by providing templates, so people can either send us rows of new data for an existing meta-analysis that we can then add to the data set very easily, or people can actually use our infrastructure to create full new meta-analysis. And if they follow our steps, these meta-analyses just are added by us, and then all of these tools are available to this meta-analysis as well. To further encourage this, we also have created educational material that is specifically based on how to do meta-analysis with MetaLab, and we have written material. We also have a YouTube video channel where you can hear me in my German accent talk you through 10 vignettes about how to conduct a meta-analysis. It's very nice. And finally, so now that we're getting more meta-analysis involved, we're trying to structure our data better. So until now, we have focused on early language acquisition because that's the field we're originating from. And that already, the fact that we have now accumulated 15 data sets on that makes it possible to look at, compare different abilities, how they emerge, and to get a more quantitative picture, hopefully, of language development. But also, we now have added a new domain. So we have restructured the website so that actually now we have an early language domain, and we just added a cognitive development domain. And right now we're envisioning that other developmental domains can be added, and each of them can be then explored. So this is the website. And by doing this, we hope to have dealt with some of these issues. It's now dynamic, it's community augmented, and we have some aid for users and conductors of meta-analysis by this infrastructure. And today, as I said, in the early language development domain, we have 15 finished meta-analysis and 6 are in progress. The cognitive development domain is just starting up. For us, importantly, we're really trying to get this away from the originators of this website. So we're trying to have others just independently of us use our infrastructure. And this is gaining traction now. It's still not really far, but I think really in the last 2 years in our field, the awareness of these things have gotten much, much stronger. So right now, actually, 11 meta-analyses are not first authored or not at all authored by the originators of MetaLab, which we are very happy about. So now I will just walk you through a few examples from the early language development domain. And the examples are actually based on 12 meta-analyses. That is just because the papers that we wrote up where we did all the analysis on were based in a time point half a year ago where we had 12 finished meta-analyses, but the general conclusions don't really change. And so these are the 4 types of insights I'll go through now. And so the first thing we were interested in as well, what's the statistical power in our field? How are we doing? And this is just an overview of the data sets. We look at an age range of 0 to 60 months, so 0 to 5 years. And the median sample size for our studies is 18, which is really not a lot. And so the median effect size across all these studies is 0.45, and the median power is 0.44 that you can deduct from that. So already with looking at this, we can see that even just looking at the data that are already included in this website, we would need much more participants than are usually tested. And this is something that is quite obvious when you look at this, and maybe it's obvious if you look at it from other fields. But right now, for instance, we have now just been accepted in a journal called Child Development, which is a major child development journal, and we are reporting these kinds of measures. And I think this is really good for the field to get this quantitative overview of how we are doing and that we have to change things. And yeah, here another view on that. So there's only 3 data sets that cross the 80% power line, which is arguably also not very much. So one thing we tried to look at is to, in this paper, to explain what you don't have to look really read the numbers, but we tried to look at why people come up with certain sample sizes, because actually for decades this number of 15 to 25 babies has been very stable in our field. So one thing we have looked at is to extract the sample size of the seminal study in each meta-analysis that we just defined as the oldest paper that was also the most cited one. And then we compared the power that would be calculated based on the seminal study with the power that comes out of the whole data set. And what we find is that often there's a big difference. So in some cases, it really seems to be that the studies in a certain meta-analysis really base their sample size decision very much on a seminal study. In some cases, it's not very obvious, and in some cases, they actually do pretty well. So this seems to suggest that people often don't make random decisions. They use a heuristic. It might just not be the best one. So another thing we wanted to look at is, well, so I guess with meta-analysis, there's always the argument garbage in, garbage out, which is, of course, true for all meta-analysis. But of course, unfortunately, there's techniques to at least get an idea of how much evidential value there is in the literature, how bad we are. And so on our website, we offer several possibilities to do that. Right now, I'll just talk about p-curve, which I think most of you are familiar with. So this is a way to plot a distribution of significant p-values in the literature. And so here you see on the x-axis p-values from 0.05 lower, and the logic would be that the more evidential value there is in the literature, the more right skewed, so like the blue line, this p-curve should be, and if there's no effect at all, no true effect, then the line should be flat. So we ran a p-curve on all our data sets, and actually this isn't really bad. So there's only one data set that is really has no evidential value at all. The rest seems to be doing fine. If we look at funnel plots, which I'm not showing here, it doesn't look that good. But so what we usually do is to, because also with p-curves, one problem with p-curves is that it's a bit hard to quantify how bad it really is. But we just think that it is a good indicator for people in a field to look at certain different types of these analytics to get an idea of how good their field in general is in terms of published studies. So while the evidential value based on these p-curves doesn't seem too bad, actually we have colleagues that have taken a closer look, and that's quite interesting. And to explain that to you, I'll take you on a little excursion into baby studies. I'm talking about, so they looked at a certain paradigm which is called head-turn preference paradigm. And what's happening is that the child is sitting in the center, and then it hears sound streams either from the right or from the left that is counterbalanced. And how long the baby looks at one side while a sound is played is taken as an indicator of their interest in that certain sound stream. And one thing, for instance, you could compare, and which has been found over and over, is that babies differentiate between types of speech sounds that they're familiar with. So an American infant would hear sound streams like, look at the dog, look at the cat, oh, that's a nice baby, versus something, for instance, in Japanese, mite mite wanzang, and then there would be a difference in their looking times. The problem with this paradigm is, and I really don't think it's a good paradigm, is that you could either expect a familiarity preference, so babies look longer at what they like and know, or you expect a novelty preference because they're curious about new things. And you can imagine how you can talk a lot about that in a very convincing way, either way. So this is actually a paradigm that I think has been misused a lot, because even if there's no effect at all, based on a sample size of 18, it can always happen that you get a significant effect in one or the other direction. So colleagues of us that have used MetaLab have actually done a very interesting thing where they looked at, where they compared the p-values from, because in each literature there's usually a dominant direction. So either most studies show a novelty preference or most studies show a familiarity preference. So within the literature there seems to be some consistency in how babies respond. But still, if you find in the literature that usually has a novelty preference, a familiarity preference, people can publish it because it's a difference, it's not a null effect. So the question is whether these studies that have the minority results are have as high evidential value as those that don't have. So these colleagues of us looked at very similar things, just that it was concerned with rule learning. In this case, baby are actually familiarized with a certain rule, for instance, an AAB rule, which is like papa gi or gigi bo, and then they're tested on the familiar kind of rule, which can be the same item or another item, just to see whether they have extracted the rule, or with a novel kind of rule that has a different structure. And there again, you could see a familiarity or novelty preference. In this case, the majority of the literature does find a novelty preference. So they divided the data sets, and it's actually a very interesting result, because you see that for the data sets that have the majority result, the p-curve looks okay, but for the one that has a familiarity preference, the p-curve looks a little bit p-hacked. And based on this, we've also looked at other studies in our database that actually seem to show a similar tendency. I'm not showing the graphs because we're not very far in the analysis yet, but this is a thing that we can now do, that we have all these data sets in the same format. That is very exciting. Another thing that is interesting for people in our field is how different testing methods affect infant results. And it is important because I don't know how it's in other fields, but in our fields, often babies tested with different results based on different methods are treated the same. So here, for instance, babies were one lab tested American infants on African click consonants, what they found, blah, 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 and then French learning infants were tested on blah, 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 and they found blah, blah, blah. So that's what usually is written in the introduction section of an article, but actually these two papers use very different methods, and they're really very different because they're based on two different psychological mechanisms. One is based on habituation, where basically you let the baby hear a sound until it's very bored, da, 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 until they don't look anymore, and then you present them ba, 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 and then if they look back, that means they have discriminated the sound. In conditioned head turn, this is a much more intense procedure where babies are actually conditioned often over several sessions, over 2 or 3 days, to show a response. So first, they start with a very easy kind of contrast. So ba 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 gi, and every time they hear gi, a very fun toy pops out on the right or left side. And so then they are trained to show this response, even though the toy doesn't pop up anymore at one point, and once they have passed the threshold, at which point also many babies drop out because they don't pass the threshold, then they are tested on the critical contrast ba-ga. So you can see that these are very different methods that involve very different labor by the baby, but people really treat them the same when they discuss qualitatively results. And as you could guess probably, we do find across all our databases that this method really matters. So the more laborsome method has much higher effect sizes, which I think is also very informative for our field. And finally, I want to present you something that is still not very elaborated, but that we're very excited about, namely that we want to try to use these different meta-analyses on one field to look at the quantitative relation between different aspects of language development. So there's different theories out there. One is that language development is very sequential. So for instance, you do need to learn speech sounds first in order to learn words, in order to learn grammar. Then there's more interactive theories that would say, well, these onsets can be simultaneous, and then they bootstrap each other into better language abilities. And then there are other theories too. So one thing we try to do here now is to put together in the early language domain all meta-analyses that we have to get a more quantitative idea of this. And this is now separated by the different subdomains in language developments we have in there so far. And it is really hard to say something conclusive based on that. But one thing we can see is that abilities seem to be rather interactive and not strictly sequential. And there seem to be some abilities that develop very slowly and continuously, and some that show more of a jump, because this is also a thing that we always wonder in language acquisition, whether an ability is not there and then it's there, or whether it develops very gradually. So we try to work on this too. It is not easy, especially because the effect sizes, even if they're standardized effect sizes, they might not be comparable across different subdomains because tasks might have a very different base difficulty. But just to illustrate to you where we also want to go with this database. That was it. And this is the team that was funded by WITS. Thank you. No questions? Well, oh, there's one.
So I was wondering how you got some people to contribute to this project already, and if there are some lessons of how to get more people to contribute, because you would want to have almost all data end up in a database like this, right?
Yes. Yeah, so indeed it was a very slow start and then it went up. And I think there's two types of contribution, right? One is to contribute just information that we would need to include a data set in a meta-analysis for single authors, and another type of contribution is to actually conduct a meta-analysis. And actually, I think both of them, we've just massively advertised what we're doing on relevant mailing lists. We try to go on have someone of us go on all relevant infant conferences to talk about it. There's much more and more method workshop, and it's really the last 2 or 3 years have seen more methods workshops in infant conferences. So the way we try to do it is so this is one way we're doing it, so publicly just advertising what we're doing and actually showing people positive examples of what they can gain from looking at these kind of data. And the other thing that we have been doing is to really personally talk to people. So whenever we see a poor PhD student standing at a poster and starting a new topic that still is not in MetaLab, we try to advertise that doing a meta-analysis might be a good idea. It can give you a publication, we can help with the process. And individually talk to PIs actually to encourage them to maybe consider their students, propose to their students to run part of or a whole meta-analysis. Yeah.
Anybody else? Any other questions? Yeah.
So I know nothing about language development, but I'm a fan of popular science readings, and it's a mix of either popular science or popular philosophy books that go always to make some sort of reference to this test about infant development, of how altruistic we are at age 3 months, 6 months, etc., etc. And those tests they fit into your category, and the consequences seems to be pretty important. And is the MetaLab sort of like focus by kind of how relevant these studies are, or are there studies that are more the ones that are more high profile, this kind of studying altruism or studying universal language or stuff like that? Is there an emphasis on replicating those studies, or?
So, I mean, we don't really do replication in this project, right? I mean, it would be great if people take wonky results here and try to replicate them, but that's not the focus. On the topics, yeah, I think this all sorts of social, moral behavior would be great to have in addition. So we just started with early language development because we study it, but I don't think that's a more relevant topic than many other domains of psychology and development. So, and right now we've started cognitive development, which is a very big umbrella term, which does not fit yours, just because we knew some people that wanted to do meta-analysis on those. But our idea would be to have different domains simultaneously and not hierarchically existing next to each other, so that they can be looked at just by themselves, and also to compare things that are comparable across these domains. Yeah.
All right, let's one more round of applause.
Thank you.